Hi everyone, I'm Mario and welcome to Code on Fire. In this tutorial we'll explore how to use a resource like the projectile component. To understand how it works in the best possible way, let's start by creating a new actor blueprint. Open the content drawer, right-click, go to Blueprint and select an actor class. Let's name it simply BP Projectile. The projectile component allows the elements of our actor class to behave like a projectile, such as a missile or any object that follows a trajectory. First, let's add this component, search for projectile and click on it. As you'll see in the details panel, there are plenty of variables and functions available to customize this component. We'll get into those later. For now, let's move on by adding another component to the class, a simple sphere, which will help us visualize how the projectile component affects the actor's behavior. Alternatively, you can use any static mesh you prefer. One key thing, make sure to set the sphere as the root component of the blueprint. This is important because to properly respond to the projectile logic, the root must not inherit transforms from other components. For now, we'll leave the projectile settings as they are. The default will work fine. To test everything, we need to spawn a BP projectile. In this case, we'll create a spawn system that originates from a specific object. I'm using this character with the current setup you see, but you can build the same spawn system using a different character by following the same steps. First, we need a reference point to spawn our actor. We'll use a simple arrow component. Search for it in the component list and add it. To align the arrow perfectly with our object, here's what we'll do. Make the arrow a child of the object. This way, it inherits the special orientation of the parent. A property you can leverage in many other contexts too. Now switch from workspace to local space. This makes alignment much easier and more precise. Now we need to add an input that lets us spawn the BP projectile. I use the left mouse button, but feel free to choose any input you prefer. Connect the input to a spawn actor from class node and specify the class you want to spawn. In this case, BP projectile. For the spawn transform, we need to provide the position and rotation of the arrow component, which will act as our spawn reference. So, bring the arrow component into the event graph and, for simplicity, connect it to a get word transform node. This will give us the location, rotation and scale of the arrow. Let's go back into BP projectile and set the initial speed to 3000, same for max speed, and check the box for should bounce to make the sphere bounce. Compile, save as usual, and return to the game scene. Hit play and press the left mouse button to spawn a BP projectile. As you'll see, the object spawns in the x-axis direction and falls to the ground while following its trajectory. Now let's look at how to customize the behavior of the projectile. The projectile moves along the x-axis due to the velocity setting in the projectile component. Right now, with set value of 1, on the x-axis, which means the projectile will follow that direction. The reason it falls to the ground is due to the gravity scale setting. If we assign a value of 0 to that variable, the object will no longer fall. From this example, it should be clear that the velocity component lets us define the trajectory of a projectile. The values assigned to each axis are used to calculate the direction vector. Initial speed sets how fast the object moves when spawned. Max speed defines the maximum speed it can reach when affected by other events. Let's try a simple example. Increase max speed to a value higher than the initial speed. Raise the bounciness value so the projectile bounces more aggressively. In the event graph, add an OnComponentHit event for the sphere. From the hit pin, drag out and add a break hit result node. Then, from the impact point pin, connect it to a spawn emitter at location node. In the emitter template, choose an explosion effect. Link the event node to the emitter node, compile, save, and hit play. You'll see the projectile keeps its initial velocity. When it hits a surface, its speed increases due to the collision event, but it will never exceed the max speed. We'll dive deeper into this topic in the future videos, so make sure to subscribe to the channel. Thanks for watching, see you soon.